Hi, my name is Karina Patel, and this is Physics 1, Lab 1, Constant Velocity. The purpose of this lab is to compare an observed model of an object moving with constant velocity to a prediction by a computational model. And the observed model is plotted object's position over time, a tracker, and then the computational model is when we use the velocity and position update formula to calculate a line in glow script. And the main physics principles we used were Newton's first law and second law. And since this is a preview of the results, the observed results is not really a straight line on the left, and then the computational model is a straight line on the right. And then the fundamental physics principles that we used was Newton's first law: an object will stay traveling at constant velocity unless acted on by a net external force. And that's an assumption we used in the computational model, where we said that the net force was 0, so that it would have a constant velocity. And then Newton's second law is acceleration is directly proportional to net force acting on it and is inversely proportional to mass. And so F equals ma can be derived into the velocity update formula, which was used in the computational model. And then the three formulas we used were velocity average, which is change in position over change in time, the velocity update, which is VF equals VI plus acceleration delta t, and position update, which is final position equals initial position plus V average delta t. And these were all used in the computational model to get the final graph. So the system is the cart on the ramp that was pushed, and the surroundings were anything that is exerting force on the system, and in this case it is a track that the cart was on. The initial conditions are initial time was 0 seconds, initial position was negative 0.081 about for the x component, and then zeros for the rest of the components. Initial velocity was 0.25446 for the x component and 0 for the rest of the components. And this was found using the formula I said earlier, which was change in position over change in time. And the change in time is 0.0333. And on the bottom right is a picture of our video and tracker. So this is my code, and you can see that t and delta t are inputted on the picture above, as well as the initial velocity and position. And then in the while loop on the bottom, I said t is less than my final time, and then I said f net was 0, and then under that I used the position update and velocity update formula. So these are the observed results and the computational model. And the observed results showed that the object did not move with constant velocity, instead slowed down due to friction between the cart and the ramp and other possible forces. And the computational model did not take the forces into account because it started with F net equals 0, so it did not get the same value for final position, and it had a different shape overall. So possible sources of error could be inaccurately placing the tracker points. Tracker is a very old software, so there could be mistakes with that. And then also maybe some minor mistakes in the calculations that I did not correct. And so what if I flip the axes? If the x-axis was flipped so that the negative and positive values were swapped, then the graph would change from a positive position slope to a negative slope. This would then change the sign of the velocity and acceleration in the x direction. The magnitudes and overall shape of the graph would stay the same though. The only thing that would change is positive to negative slope. So then what does it mean? In the calculations, I did say that there was 0 net force, and I would assume gravity, friction, and normal force are all acting on the cart as it traveled along the track. However, this might not be all of the forces, because there could possibly be air resistance or others that we have not discussed in class. So I cannot exactly say how many pushes or pulls are being added together to get a net force of 0 in total. So in conclusion, in this lab, the motion of an object was observed and plotted with tracker. It was then compared to a computational model with the assumption that the net force is 0. The model's predictions do not perfectly match the observed results, but these differences could be due to human error, or that the assumption that F net equals 0 was not applicable in this situation. Thank you for listening.